All right, sorry I had to split it to 3 videos, but my recording program will only do 15 minutes, and I was right at 14 minutes and something seconds. So I had to cut you guys off. So to finish, we are on our last, the last condition. As I said, there's 5 conditions: linear, independent, normal, equal variance. And in the last video, I tried to explain a little bit of all of those. So on the equal variance, I know I kind of cut that one short. We had to look at a residual plot that shows the similar scatter for all values. And I showed you on the calculator how to do a residual plot. That's list 1 of the explanatories against list 3, which was the residuals. And we just need an even scatter, okay? We don't want to see that curved pattern. If you guys remember me showing you guys the curved patterns at the beginning of the year. We just want nice, even scatter around this bar. That says equal variance, okay? Remember, variance is a measure of spread. We just want them evenly spread out is basically what it's saying. So we have one final condition, and it's an easy one. It's the random condition. It's the condition that we've always worked with in all the other samples we've done. So random, all you gotta do is quote the problem. It's a random sample of 9 students. So I know this video is going to be short and sweet and to the point, but as I said, whenever we're checking conditions for inference, first check L for linear. Make sure that your scatter plot is linear. Put in your data into list 1, list 2, and show the scatter plot. You want to see some kind of line. And you're going to say the scatter plot of whatever your explanatory is, whatever your response is linear. Okay? On the independent condition, you're just saying that each of the samples that you've taken are independent of each other. Like one will not affect the other. So in the case of GPA versus ACT, one student's GPA and ACT score is not going to affect another. But usually random sample takes care of that, so we can just use this sentence, random sample, ensure that the individual observations are independent. But then we have to add in the 10% condition if we indeed do SRS, okay? Normal, we just got to show that the histogram of the residuals is roughly normal, so put in your histogram, your residuals into list 3. Look at a histogram, or instead of a histogram, look at a normal probability plot. You want the normal probability plot to be approximately normal. So in that case, I'd say a normal probability plot of the residuals shows that it's linear, which means it's roughly normal, okay? But you specifically have to say what you checked. Histogram of residuals, show the picture. Or if it was a normal probability plot, say normal probability plot of residuals is roughly normal. Something along those lines. Equal variance, again, is just even spread of the residuals. So notice that I mentioned the fact that it was a residual plot, and I drew a little picture of the residual plot to show that there was indeed even scatter. And then the random condition, like I said, is just making sure that it talks about the fact that you got your sample from any kind of random aspect. All right, so you're going to be practicing a lot of this, checking the conditions, and remember 5 conditions, L-I-N-E-R, which is liner, to help you remember. All right, you'll see some more of these in the next couple videos for the next lessons. We'll continue to practice this. Good luck on your homework tonight.